Hi there. Let's assume that the probability of randomly selecting a Westfield resident who supports the ACA is 0.35, and let's assume that support is independent from person to person. In this case, then, we have a very special probability distribution that we need to review. So to calculate the probability that 3 out of 4 randomly selected residents support the ACA, we can use a binomial distribution. X will be distributed, where X is the count of the number of supporters. X will be distributed binomially with 4 trials, 3 out of 4, and the success probability that we are assuming is fixed is 0.35. So here are the 4 conditions. There have to be only 2 possible outcomes. Either you support or you don't support the Affordable Care Act. There has to be a fixed number of trials, that is 4. The fixed success probability is 0.35. And then by assumption, the outcomes need to be independent of each other. So we can actually make the probability distribution. We can list all of the possible outcomes, 0 to 4 supporters. We can put those into list 1, and then we can find the corresponding probabilities and store them into list 2 using the Binomial Pdf command. So let's take a second and do that. So if you have any data in list 1 and list 2, you should go up to the top and clear it. So I'm going to enter 0, 1, 2, 3, and 4. These are the possible outcomes. Now I'm going to go to the home screen and I'm going to call up the Binomial Pdf command. So second variables takes you to those distributions that we've used many times. Here is Binomial Pdf. So the number of trials are 4. The fixed success probability is 0.35, and then notice that the value of X, or the particular number, the particular count for which I want to find the probability, I stored those into list 1. So if I paste this onto home screen, then I want to take those probabilities and I want to store those into list 2. So if you actually press Stat and enter, you can see then on the screen, here are the possible outcomes, 0 to 4 successes, and here are the associated probabilities. So that list of the outcomes with the associated probabilities is a probability distribution. And for this to be a valid probability distribution, notice all of the probabilities are positive. Of course they are. Here, and the sum of the probabilities, so I could take the sum of list 2, that sum should be exactly 1. We can verify that here by literally going to second list. If you go over to math, then you can find the sum option. So it's not something you want to do by hand. Oops, I'm doing it in the editor here. That's not what I want to do. Sometimes that happens. So I'm going to clear that because we should be doing this command from the home screen. So second mode takes me back to the home screen. That's where I want to do this command. So second stat, and then over to math. Sum is option number 5. And I want to take the sum of list 2. There we go. It should be 1, just like we expected. So going back to our practice questions then, let's find some probabilities. Using the Binomial Pdf command, we can answer the question from the very top and find the probability that X equals 3, that we have exactly 3 successes. So we can do that by pressing second variables. We'll go to the Binomial Pdf command. So you got to scroll down to it here, or you can just press the number, or the letter. In this case, it's option A. So we have 4 trials. The success probability is 0.35, and the X value that I'm interested in is exactly 3. So we'll paste that to the home screen and execute that command. So that probability is approximately 0.11. Of course, we could have done that just by looking it up in the table, because we have the entire probability distribution. The probability of exactly 3 successes is 0.11. I can see it right there already in the table, but you can use the Binomial Pdf command to calculate it directly. So what I want you to see, though, is on the formula sheet, this is the notation that is given. This is the binomial theorem. This is another way to do that same calculation. So notice here is our success probability raised to the power 3 because we want 3 successes. That means we want 1 failure, so we're multiplying by the 0.65, and we can multiply because these are all independent of each other. The trick is this here. This combination right here is equal to 4. We can actually get that by using Pascal's triangle because there are 4 different ways that I can have 3 successes and 1 failure from among 4 randomly selected individuals. So notice, if you recall using Pascal's triangle, here is the triangle. So in order to get this number here, the number of ways that this combination can happen, we have to go to row 4, that has the 4 in it, and I am looking for 3 successes. So this 1 represents the number of ways we could have 0 successes. This 4 is the number of ways we can have 1 success. This 6 is the number of ways we can have 2 successes. And then finally, this 4 right here is the number of ways that we can have 3 successes. So if you take the time to actually put this into your calculator, that notation represents the same thing as using the Binomial Pdf command. So literally, we can take 4 times our success probability of, our success probability of 0.35. We want to take that and raise it to the 3rd power. And then we want to multiply, I still missed it. There we go. And now I got a 33 there. Let's delete one of those 3's. So, and then we want to multiply that by the 0.65. As you can see, by the way I'm typing on the screen here, it's probably a whole lot easier just to use the Binomial Pdf command. There's the same option right there. It's just the way the calculator calculates it, or at least the way it's shown on the formula sheet. So let's not work too hard here. We already know the probability of equaling 3. So that means the probability of not equaling 3 would be everything not included here, 1 minus the 0.11. So that would give me 0.89. So here, I want the likelihoods that x is less than or equal to 3. I want all of those options. So we could go to the calculator. I can press stat and enter, and if we wanted to, we can add up all these probabilities for 3 and 2 and 1 and 0. You can add up all of those if you want to, but the binomial CDF command will do that for you automatically. So again, second variables will go to our commands. My guess is that it is option B on the calculator emulator you're looking at on the screen here. There it is. There's the binomial CDF command. 4 trials, a success probability of 0.35, and I'm interested in adding up all of the probabilities of the success counts from 0 all the way up to and including 3. So there you go, 0.985 we'll call it. So notice the probability that x is less than 3, I don't want to include the 3. So this is the probability that x is less than or equal to 2. Again, we could use the binomial CDF command to calculate that. I'm going to press second enter just to bring the command back up to the home screen, and I'm just going to edit it, changing the 3 to a 2. So there's the new one, 0.874. There we go. So notice then, I am interested in this last one, the probability that x is greater than or equal to 3. So that's really just the probability that x equals 3 or 4. So literally, we could go here and just add these up. I want the likelihoods of 3 and 4, so I could add up those probabilities if I wanted to, although I've got another trick that I would rather show you. So the probability that x is greater than or equal to 3, that is equal to 1 minus the probability that x is less than 3. Well, we just found the probability that x is less than 3, so it'd be a whole heck of a lot easier just to take 1 minus the 0.874. So forgive me, I don't remember what that is, so we'll go to the calculator, go back to your home screen. So 1 minus 0.874, there it is, 0.126. another alternative to just using the table. So there are formulas then for the expected value and for the variance of a random variable. Those formulas are given to you on the formula sheet. This is the formula for expected value and the formula for variance. But remember, we have a calculator program that we could use to calculate the expected value and the variance when the counts are in list 1. So when the success counts are in list 1 and when the probabilities are in list 2, you can run the program rvm_vs, and that will give you the mean, that will give you the variance, and that will give you the standard deviation. So if you look on the back side then, you also have formulas for these. You can get the exact same thing by looking on the formula sheet, because another way to find that same expected value is just to take n times p, 4 successes times the success probability of 0.35. That will give you exactly the same value of 1.4. And the square root of n times p times 1 minus p, that would be 4 times 0.35 times 0.65. That's another way to get the standard deviation of 0.95. So before you look at the practice question, something I want you to think about: binomial probabilities can be approximated using z-scores and the normal density function, but that is only when the counts of successes and failures, so when n times p and n times 1 minus p, when both of those counts are greater than or equal to 10. So notice in this case, that does not apply, because notice the mean here, the expected value, is the number of successes that we would expect. That count is only 1.4. So notice the number of failures, you could take 4 times 0.65 if you wanted to, but if there are 1.4 successes out of 4, that means that there are only 2.6. I can just take the 1.4 and subtract it from 4. That means there are 2.6 failures out of 4. So the truth is those counts aren't anywhere close to being greater than or equal to 10. This is why the normal approximation is not appropriate in this context. So try practice question number 1 using the Binomial Pdf and CDF command. You can use the formulas for expected value and standard deviation for the binomial distribution. Explain why the normal approximation is appropriate. I actually want you to try using a z-score to recalculate a probability. Run the norm-win program to get the right window set. Try using the shade norm command, labeling your diagram and drawing to represent your probability and showing your work with a well-labeled diagram. And then in practice question number 2, look at the formula sheet, because something really important here. Not only do we have probability distributions, but we also have sampling distributions that we can use to calculate probabilities. You should recognize everything in practice question number 2, but in order to fill in the blanks there, you probably want to take a look at the formula sheet to remember the relationships for standard deviation that are true for these random variables that we are looking at, for the random variable p hat and x bar. Hope this has been helpful.